Welcome to our channel The Digital Book. We had come yet with another metallurgy topic, the classification of engineering material. Let's start. First of all, let's take a look into the total classification chart of engineering material, which constituent of total 21 elements. Further, we will study about each and every element dividing into parts. From top of the chart we can see the engineering material is classified into 4 subdivisions, in which number 1 is metal, number 2 is polymer, number 3 is ceramics, and number 4 is composite material. Further, metal is classified into 3 categories. First is ferrous, second one is amorphous, and third is non-ferrous. Then we see polymer is subdivided into 3 subcategories. First one is thermoplastic, second one is thermosets, and third one is elastomers. Then coming to ceramics, which is classified into 6 categories. Number 1 is glasses, number 2 is clay product, number 3 is refractories, number 4 is abrasives, number 5 is cements, and number 6 is advanced ceramics. And the 4th category of material is composite material. Further, which is classified into 4 categories. First is polymer matrix composite, MC. Second is metal matrix composites, MMC. Third one is ceramics matrix composite, CMC, and fourth one is hybrid composite. Let's discuss thoroughly on our first engineering material, metals. Definition of metal. Metal is a material, an element, compound, or alloy, that is typically hard, opaque, shiny, and has good electrical and thermal conductivity. The most common examples of metals are iron, steel, aluminum, silver, gold, platinum, brass, bronze and copper, etc. Again, recalling the classification chart, metal is classified into 3 forms: ferrous, amorphous and non-ferrous. Let's see the definition of ferrous metals. Ferrous metals include cast iron, steel, and the various steel alloys. The only difference between iron and steel is the carbon content. Cast iron contains more than 2% carbon, while steel contains less than 2%. Secondly, let's take a look on class of amorphous metals. The definition is: amorphous metals are made from alloys whose constituents may include iron, nickel, and cobalt, and a metalloid or glass former, such as silicon, boron, or carbon. And third classification of metals is non-ferrous metals. Let's see the definition of non-ferrous metals. Non-ferrous metals are metals that do not contain iron. Examples include aluminum, zinc, copper and brass. The main application of non-ferrous item. We can find that in medical equipment, electrical and electronics applications, auto parts, and aircraft industries. Coming to next polymer, which is subdivided into thermoplastic, thermosets, and elastomers. Thermoplastic polymers. They are those polymers which can be softened on heating and hardened on cooling room temperature. They may be linear or branched chain polymers. These polymers can be recycled many times. X, polyethylene, polyester, PVC. Coming next, thermosetting polymers. This polymer is hard and infusible on heating. These are not soft on heating under pressure, and they are not train molded. These polymers are cross-linked or heavily branched molecules. These polymers we cannot reuse or recycle. Some common examples are bakelite, ureaformaldehyd resins, etc. Next coming classification of ceramics. Ceramics are further classified as glasses, clay product, refractory, abrasives, cement and advanced ceramics. First of all, let's see the definition. A ceramic material may be defined as any inorganic crystalline material, compounded of a metal and a non-metal. It is solid and inert. Ceramic materials are brittle, hard, and strong in compression, weak in shearing and tension. Glasses are transparent material which is formed by quenching of material in liquid so fast that the atoms cannot rearrange itself in crystalline form. A glass is a hard bright material used for making of jars, container, window, bulb, bottles, etc. Next definition. Clays are used in industries largely because of their contribution to the molding and drying properties of the wares being produced. Many clays, such as the flint clays, are used because of favorable behavior during firing or because they produce favorable properties in fired ware. Next definition is refractory materials. A material having the ability to retain its physical shape and chemical identity when subjected to high temperatures. Refractories, bricks of various shapes used in lining furnaces. Refractories are inorganic, non-metallic, porous and heterogeneous materials, composed of thermally stable mineral aggregates, a binder phase and additives. Next definition is abrasives. Abrasives is classified as family of hard materials that can be used for polishing, smoothing, and grinding the surface of other materials. Some abrasives are hard enough to cut many hard materials. Diamond is natural abrasive. Next classification of ceramics is cement. Cements are finely ground powders that, when mixed with water, set to a hard mass. Setting and hardening result from hydration, which is a chemical combination of the cement compounds with water that yields submicroscopic crystals, or a gel-like material, with a high surface area. Next classification of ceramics is advanced ceramics. Advanced ceramics can be defined as the substances possessing exceptional properties that makes them highly resistant to bending, stretching, melting or corrosion. Few examples of advanced ceramics are alumina, zirconia, silicon nitride, silicon carbide, etc. Next classified as composite material, which is further classified as metal matrix composites, polymer matrix composite, ceramic matrix composite, and hybrid composite. Definition of composites. Composite materials defined as mixtures of two or more components, combined physically with each other. One of these components called the reinforcing phase, or the discontinuous phase, while the other called the matrix, or the continuous phase. Coming to the first point, metal matrix composite. The definition is: the well-known metal matrix composites, MMC, are aluminum, magnesium and titanium composites. The reinforcement of these composites are carbon reinforced with steel, or epoxy resin reinforced with graphite heat fibers, and many other examples. Coming to the second point, polymer matrix composite. The definition is: polymer matrix composite is considered as the most popular composites. Young's modulus, higher usage temperatures, larger values of comparing with the ceramic matrix composites, or metal matrix electric and thermal conductivity, and better resistances to the composites, due to three reasons: its lower cost, its high wear, fatigue, and deformation. The third classified as ceramics matrix composite. The definition is: ceramic matrix composites is recognized with their higher strength, higher application temperature, their chemical, the ideal fibers inertness, and their low densities in most high temperature applications. It is widely used materials in manufacturing of cutting tools that insert within oxidizing and strength, stiffness, higher strength weight ratio. and other mechanical properties. The fourth one, classified as hybrid composite. The hybrid composite is the addition of a second type of fiber, such as glass or aramid. Applications of these composite are multiple, such as their using fibers leads to increase the toughness. The demand of the carbon fiber is in aerospace, automotive, and construction. At the end of the topic, let's see the classification chart again. Thanks for watching the video. And please like, share, comments and subscribe, and don't forget to watch our next video on the topic crystal structure.